Why is the integral of e to the power e just e to the power e, but the integral of e to the power 3x isn't? Today, we'll uncover the simple rule that makes exponential integrals automatic. The exponential function is its own derivative, and therefore its own integral. Because the derivative of e to the power x with respect to x is e to the power x, integrating brings us right back to where we started. The integral of e to the power x dx is equal to e to the power x plus c. No other function has this property. The exponential function e to the power x is the only function that is unchanged by differentiation. This is what makes exponential integrals so elegant once you understand the pattern. But what happens when the exponent isn't just x? Here's the general rule. The integral of e to the power ax dx is equal to 1 over a e to the power ax plus c. We'll divide by the derivative of the exponent. Since the coefficient a in the exponent comes down when differentiating, we compensate by dividing by a when integrating. This is u-substitution in disguise. If we let u equals ax, then du will be equal to a times dx. But since we only have dx in our integral, if we divide both sides by a, dx is equal to 1 over a du. The rule follows naturally. Let's look at our first example. If we integrate e to the power 5x dx, here the exponent is 5x. Therefore, a is equal to 5. If we apply the general rule and divide by the coefficient, the antiderivative of e to the power 5x with respect to x will be equal to 1 over 5 e to the power 5x plus c. We can always verify by differentiating. The derivative with respect to x of 1 over 5 e to the power 5x plus c, well, the derivative of the constant c will be 0. So that will be equal to 1 over 5 times the derivative of e to the power 5x is 5 times e to the power 5x. So 1 over 5 times 5 is 1. We're left with e to the power 5x, which is what we started with in our integral. In this next example, we have a negative exponent. We want to integrate e to the power negative 2x dx. In this case, our exponent is negative 2x, so a is equal to negative 2. So if we apply the rule, the antiderivative of e to the power negative 2x dx will be equal to 1 over negative 2, a coefficient, times e to the power negative 2x plus c. And this can be rewritten as negative 1/2 e to the power negative 2x plus c. The rule is identical. Always divide by the coefficient of x, whether positive or negative. But what if you have a constant out front? Constant out fronts are handled separately from the exponent's coefficient. So if we have the integral of 4 times e to the power 2x dx, we'll want to pull the constant out, apply the rule, and then multiply back in. So our answer will be 4 times the antiderivative of e to the power 2x with respect to x is 1 over 2 e to the power 2x plus c. And then we can simplify 4 times 1/2 is 2. So that will be 2 e to the power 2x plus c. Here's the big pattern. Whenever you see an exponential multiplied by the derivative of its exponent, for instance, if you have integral of e to the power gx times g prime of x, that's the derivative of the exponent, the integral is simply e to the power gx plus c. No division needed because g prime of x is already present. Here's how to spot it. You'll want to identify the exponent function g of x, check if its derivative g prime of x appears as a factor. If yes, the answer is immediate, that's e to the power gx plus c. If no, you'll use u-substitution to create the pattern. So if we look at this next example, we want to integrate 3x squared times e to the power x cubed dx. In this case, if our exponent is u x cubed, Its derivative is 3x squared dx, which with what we have here. So if we let u equals x cubed, du is 3x squared dx, we can use substitution. This becomes integral of e to the power u because x cubed is u, and 3x squared dx is du. And this antiderivative will be e to the power u plus c. We can substitute back, and that will be e to the power x cubed. Exponential integrals aren't hard. If you see the inside function's derivative already present, you already know the answer. Recognize the pattern, apply the rule, and always verify by differentiating your result. If not, you can use u-substitution. Thanks for watching. Please like and subscribe to keep learning with us. And remember, math success starts when you stay on the fast track.